So we are moving into our parallelograms, our quadrilaterals. So this is our quadrilateral unit. Quadrilateral being a four-sided figure. It is the family of any shape that has four sides. So the first thing that we are coming up to on our note sheet is a flowchart of quadrilaterals. And it's kind of giving you the hierarchy. So quadrilateral being the overarching figure. And then we get a couple of different branches off of this. So we can see this one branch to the right is giving us the trapezoid, where these are shapes that have at least one set of sides parallel. And if I look at the other side, on the left-hand side, a kite has no sides parallel. And if we keep going down the flowchart, I can see off of trapezoid, we get a parallelogram. So a parallelogram now, instead of having at least one set, now I can say has two sets of parallel sides. And off of a trapezoid, we also get something called an isosceles trapezoid. It's a little fancier. It's a trapezoid, so at least one set of sides parallel, that has now two congruent sides, just like an isosceles triangle. Also, like an isosceles triangle, we can see what's called the base angles. So I see these two up on top. These are base angles. Over here, I can see these two on the bottom. And again, just like an isosceles triangle, we can see that the base angles are congruent. And if we keep going, we get some other properties we will be looking at in the next few sections, where we get a rectangle. So it has two sets of parallel sides, and it has four right angles. And if I look at this other shape, we get a rhombus. So now I have, again, two sets of parallel sides, but now I get the property that all four sides are going to be equal. And then we get a square. So when we're looking at this flowchart, this is really helpful if we can have this memorized. And two words that we want to connect with it. If I were to read this chart going from the top down, the word I want to use is sum. So for instance, we could say some quadrilaterals are squares, some quadrilaterals are kites, some quadrilaterals are parallelograms. But I can't say all quadrilaterals are squares, because they're not, because I know I could get a plain old parallelogram, or I could get a plain old trapezoid. Right? Well, how do I get the word all? Well, if I read it going from the bottom up, now I get the word all. I can say all squares are quadrilaterals. All rectangles are quadrilaterals. I can even see all parallelograms are trapezoids, because not only do they have two sets of sides parallel, but they have the qualification to be a trapezoid with one set of sides parallel. So we want to make that connection. Okay, so we're going to practice some properties with trapezoids and discuss some properties with trapezoids and parallelograms. So it says, okay, in the diagram below, we have a trapezoid, and we know that AB is parallel to DC. So there's our at least one set of sides parallel. And it said, what must be true of angle pair A and angle pair D? Okay. And then also, same thing if we look at the other side with angles B and C. We're going to go back in our parallel line unit, and I know that these are two parallel lines. And if I were to cut it by a transversal, and I look at angles A and angle D, well, I can say angle A and angle D are same side interior angles. And if my lines are parallel, well, I know same side interior angles are supplementary. Okay. If we do the same thing with B and C, well, we get the same idea. It's just a different transversal, where I have my two sets of parallel lines. And now B and C are also same side interior angles. And so those also have to be supplementary. So that's always the case. Whenever I'm looking at a trapezoid, I can always tell those two angles, if I find my parallel lines, and I can find that transversal, they'll always be supplementary. So with it in mind, if we look at letter B, it says, so if angle A is 5x minus 15, and angle B is 5x minus 2, and angle C is 2x plus 7, we want to find the degree of D. Well, D is not labeled, no big deal. I know B and C are supplementary, so that's going to give me an equation. So I have 5x minus 2 plus 2x plus 7. If those are supplementary, we can set that equal to B, 180. Okay, combining like terms, I have 7x plus 5 is equal to 180. Subtracting the 5 from each side, now I have 7x is equal to 175, which is going to leave us with x equaling 25. Now keep in mind, we are trying to find the measure of angle D, and it's not labeled. So now I have to think, well, how are we going to do this? Well, if I find the measure of angle A, which we could by plugging in that 25 and solving, we're going to find the measure of angle A is going to equal 110 degrees. And we know that A and D are supplementary. So if I'm trying to find D, all I have to do is subtract from 180, and we're going to find the measure of angle D is going to be 70 degrees. Right? Some more properties of trapezoids now for looking at some other angles. So we have back here our lines are parallel MN and QP. We know measure of angle M is 108. Angle P is 4x minus 15. And we know Q is 3x plus 21. They want us to show why is N 127. Well, same idea. I know M and Q are same side interior angles. So because they are same side interior angles, we should be able to add those two angles up and set them equal to 180. And then we can solve for x. So again, combining like terms, I get 129 plus 3x equals 180. Subtracting the 129 from each side, I get 3x is equal to 51, which shows us x is 17. Okay, but we're still trying to prove why n is 127. Okay, well, n and p, again, are going to be supplementary. So if I could find the measure of angle p, which we can, we're going to plug in that 17 and solve. We know measure of angle p is 53 degrees. Okay, so if p is 53 degrees, and I'm trying to find n, because those are same side interior angles, I should know that, again, they're supplementary, and if I subtract that out, I have 127 degrees left. There's that measure of angle n. That is why it's 127. Okay. Looking at number 3, now we're going to be dealing with different angles, and it's isosceles. So just like we said in the beginning, if it's isosceles, we get two equal sides, and they're telling us we have our parallel sides here, and our two equal sides are AD and BC. So we know measure of angle BAD is 2x, and we know the measure of angle BCD is 3x plus 5. And they want us to find the measure of angle BAD, so we're looking for this one. Okay, so because it's an isosceles trapezoid, we said from the front, our base angles would be equal, both sets of base angles. So here's a set of base angles, and then A and B are base angles. So if that's the case and I'm looking for D, well then that means D also has to be represented as 3x plus 5. And now we're right back to where we were on the other two problems. Those angles are supplementary. So if I add them up, set them equal to 180, we can solve for x. So if we combine like terms, I have 5x plus 5 is equal to 180. And if I subtract 5 from each side, I get 5x equals 175, which means x is 35. Now again, we're not done. We're trying to find the measure of angle BAD. So we have to go back in and plug that in. So that means measure of angle BAD when we solve is going to be 70 degrees. So on number 4, we're going to be asked to do a little bit of a proof. And it says we know that it's a parallelogram. So knowing it's a parallelogram, keep in mind what we know. We now have 2 sets of sides parallel. So we know that to begin with, just from that word. It says list all the pairs of supplementary angles based on the fact that I have 2 sets of parallel lines. So I know these 2 are parallel, and I know these 2 are parallel. Right, well, we're going to get a whole bunch of supplementary angles. Think about what we did with the trapezoid. So we were able to take these 2 lines as our parallel lines and use a transversal. We found, well, A and D are supplementary. So I could say angle A and angle D. And then we did the other side with the other transversal, and we found angle B and angle C would be supplementary. But now, if we take this and we look at the other 2 sets of parallel lines, so this time it would be AD and DC, and we pick a different transversal, for instance, AB, well, now I get another 2 sets of angles. So they get angle A and angle B. And same thing with the bottom transversal. This is the transversal. Now I get angle C and angle D. So now with parallelograms, we can see we get 4 sets of supplementary angles. And now we want to prove that not only are we finding supplementary angles, but that we're finding A and C are congruent. In other words, meaning opposite angles of a parallelogram are equal. Special property to parallelograms. Okay, so the way that we're going to do that is we're going to draw in this line creating 2 triangles. So first things, let's get our shape. We're going to draw in this line. We can see our 2 triangles. And we're going to do kind of a 2-column proof here, where our given information is the fact that we know that ABCD is a parallelogram. We said, okay, if it's a parallelogram, maybe properties that we know. Not only are 2 sets parallel, but we also know we have 2 sets of opposite sides congruent. So I could tell you AB is congruent to CD. And I could tell you AD is congruent to CB. And that's a property of parallelograms. We know that opposite sides of parallelograms are congruent. So just like our other triangle proofs, I'm going to go and I'm going to mark up congruent. And we still have that reflexive property. That's kind of nice. So I could say BD is congruent to DB. And that's a reflexive property. There's our 3 congruent steps. So that's cool. That allows us to prove our triangle's congruent. So ABD is congruent to triangle CDB. And we have that by side, side, side. I forgot to mark reflexive. Go up there and do that just so we can see. Okay, so if our triangles are congruent, we've always been able to follow that up with that corresponding parts of congruent triangles are congruent. And one of the parts we want to prove is that angle A is congruent to angle C, and we can do that. Angle A is in one triangle, and angle C is in the other. And our last question doesn't give us a picture, but notice the hint, draw a picture. It says we have a parallelogram. So I'm going to give myself a picture, I'm going to label it, and I'm going to go in either a clockwise or a counterclockwise motion. I'm not going to zigzag around. So I have a parallelogram LMNP. We know what angle L is, and I know what angle M is, and I know what angle N is, and it says what's the measure of P? Well, looking at the picture, I know that the measure of angle L equals the measure of angle N. Opposite angles of a parallelogram are equal. So I'm going to set them equal. And I'm going to solve. So if I move over the 6x, I now have 2x minus 41 is equal to 3. And if I add over the 41, I'm going to find 2x is equal to 44, which means x is equal to 22. Okay, and I'm trying to find the measure of angle P. Well, again, I know opposite angles are equal, so I know P and M must be equal. So the measure of angle P is equal to whatever the measure of angle M is. And measure of angle M, they told us, is 2x plus 1. So I'm going to substitute in place of x, 22. So 2 times 22, I have 44 plus 1 is 45, and I can now see the measure of angle P has to equal 45. I lied. Yep, that's 45. Okay, hope this helped. Good luck. We'll do some more in class. And don't forget, like and subscribe.